Hey you guys, this is Mr. Sal. We're going to look at the discriminant, which is the square root portion of the quadratic formula. So thanks for watching. Don't forget to like, comment, and subscribe. The discriminant in the quadratic formula is this b squared minus 4ac. So, if we look at the full formula, the discriminant, right, is just whatever's inside that square root. And whatever is inside that square root will determine how many answers we have and what type of answers we have. If we evaluate the inside of that square root, which is the discriminant, if we evaluate that, then we should find if it's positive, if the evaluation is positive, then we should expect two real answers, okay? If it evens out and then you end up with 0, then you should expect one answer, right? Because the 0, square root of 0 is just 0, and when you add and subtract 0, it just goes away, whether you add or subtract it, okay? Which is why we should end up with one answer. And then if by chance we evaluate it and get a negative, then we get unreal solutions, right? Because we're taking the square root of a negative, which would give us an unreal answers, or an imaginary answer, okay? Too complex, not real solutions. So that's what that table's telling us. Just so we understand this in terms of graphing, not that anyone cares most of the time, but if this was my graph, right, with my x and y axis, if the discriminant is positive, then we should end up with a graph like something like this. The reason why it looks like this is because it would intersect the x-axis in two places. If the discriminant is 0, then we end up with something like this, where it just barely touches the x-axis one place.
So the discriminant is the negative, the red line?
So yeah, the red is if the discriminant is positive. The purple is if it's 0. And then finally, green is if it was a negative, then we should end up with something maybe like this, which doesn't touch the x-axis. So how do we end up with two solutions? Well, they're not real. So it's going to touch this on the imaginary plane, which is completely imaginary. And we love that. Determine the number and types of solutions for this equation. Okay, not too bad. Let's look at the discriminant. All right, I can identify my b value as 8, so I'm going to replace the b with 8. And then my a value, coefficient of x squared, is 3. So I'll replace the a. I said 3, didn't I? I meant negative 3. And then the c value, right, is just a constant, positive 3. All right, multiplying these, or evaluating this, 8 squared is 64. 4 times negative 3 times 3 should be negative 36. So I've got 64 minus 36, right? That eventually becomes plus, minus a negative. So we have 100, which is positive. And since it's positive, we should have two real answers. There we go. Real or rational. Either way is good. Determine the number and types of solutions for this one. All right, same idea. Let's look at the discriminant. Now this time my b value is a negative. That's not going to matter because it's squared anyways, but we'll still show it as negative 10. The a value is not shown, but it's a 1 there. It's that phantom 1. So I'll replace my a with 1. And finally, c, the constant, is 25. All right, let's evaluate this. Negative 10 squared is 100. Minus, well, we can do the multiplication there. 4 times 1 is 4, times 25 is 100. And 100 minus 100 is 0. So it's not 0, technically is not positive or negative. So we just say it's 0, right? Which means we should technically end up with one solution. Determine the number and type of solutions for this one. All right. I mean, you know, by the process of elimination, we should kind of know what's coming, but let's evaluate it anyways. And in this case, our b value is that phantom 1 right there. 1 squared is pretty nice to evaluate as well. Then we got an a value, which is this 4. So we'll replace the a with 4. And then finally our constant is 2. So we'll replace that with 2. We don't really have to evaluate this to understand that it's going to be negative, but let's do it anyways. 1 squared is 1, minus 4 times 4 times 2, 32. And 1 minus 32 is negative 31. So this time we got a negative, which is important to notice on that, right? Because it would really be the square root of that. So we know they're imaginary. And we should, thanks. we should have 2 automatically since it's not 0. So 2 imaginary solutions. So writing the equations, they're going to give us the solutions to the equations. Now we understand the solutions come from the factored forms, hopefully, right? And they're using a and b, which I don't like because of the standard form for quadratic equations, right? ax squared plus bx plus c. Well, you can use whatever letters you want there, just not x or y, if ab kind of bothers you, right? In any case, what they're saying here is if they told you one of the solutions, x was whatever you want, negative 5, then in one of these would say x minus that negative 5 would be one of the solutions, right? But since it equals 0, we could just equate it to 0 and then solve, well, I'm sorry, if we solved it, that would have given us what we started with, right? So let's look at the factored form of that. And we'll make that plus since it's minus and negative. And let's say the other one was, they said x was, all right, let's say x is 2 then. Well, then we'd have x minus that 2. And that, of course, equals 0 from the form up here. But now we just got to distribute, right? So x times that parentheses and 5 times the parentheses, and then we would simplify whatever that expression is. We'll get enough practice with that. We don't need to finish this off, but that's what they're trying to get us to do, is find the actual quadratic form for the solutions, which we will do. Find the formula in standard form, so that's the way they want it, ax squared plus bx plus c. For a quadratic that has the roots, x is negative 4 and y is 3, right? So we'll set this up. We got x minus one of the values and x minus the other value. And this should equal 0. We'll start with that negative 4, and then we'll put in the 3 as well. Now I got minus that negative, which we do need to remember. If we have a negative, it's minus the negative, which really changes that to plus. All right. So we'll distribute. I've got x times that set of parentheses, x times x minus 3. And then I've also got that positive 4 times the same x minus 3. And that'll equal 0. But let's go ahead and distribute the x. So x squared minus 3x.
Is that leading coefficient?
All right, let's distribute that 4. And it's in a parentheses, so positive 4x and then a negative 12. Yeah, that equals 0, but we can combine these two like terms. Negative 3x's plus 4x's would be positive 1x's. And we got that x squared, that's a positive 1x. And then minus 12. That equals 0. Or you could say 0 equals that stuff. Either way. Trying to think if on the homework they wanted the y equals there. As far as I remember, this is all we really needed. There we go. Now we got some imaginary values on these. But the setup is exactly the same. And we'll start with, that's a 2 plus 5i. But I want that in parentheses because it's minus that stuff, right? And then the other one is 2 minus 5i. All right. I don't like that minus being there with a set of parentheses because it's going to change the signs on those, right? So I'm going to rewrite these as kind of like distributing the negative or changing the signs. X minus 2 minus 5i. And then this one would be x minus 2 plus 5i. So now I have two trinomials that we need to distribute, which again is why we've veered away from FOIL, even though you may use it if you want. So let's look at distribution on these. So I've got x times this parentheses, and then I've got negative 2 times the parentheses as well, and then the negative 5i times the parentheses. All right, let's do the distribution here. So I'm going to distribute my x, my negative 2, and my negative 5i. Let's go ahead and look and just see what we can cancel out in this. I've got a positive 5xi and a negative 5xi. Those are going to cancel. And, the negative 10i and the positive 10i, those are going to cancel. That looks like everything that we have that will cancel. So let's look at some like terms. I got x squared there. And then I also have this negative 2x with this negative 2x, which is negative 4x. I also got that positive 4 right here. And I'm going to look at this negative 25i squared. I squared, if we remember, hopefully, is negative 1. So I really got negative 25 times negative 1, which turns out to be just a positive 25. So that 4 I'm going to combine with that positive 25 from the negative 25i squared. Well, now I've only got one final set of like terms to combine, just the 4 and 25. 4 plus 25 is a positive 29. That's it. All right, we'll change this into a quadratic with these two solutions. The same form applies though. Hope I gave myself enough space there. Let's start with this negative 2 plus 3 root 7. There we go. And yeah, I do want that in parentheses because it's minus that stuff. Then we got minus this other stuff, so that's a negative 2 minus 3 root 7 in parentheses. So rewriting this again, but without the parentheses, I've got x plus 2 minus 3 root 7. And then I've got x plus 2 plus 3 root 7. Now, I mean, we may look at this and think we have conjugates, right? But they're not. I mean, stuff is going to cancel out, don't get me wrong. But conjugates usually are only with the binomial stuff. So let's do our distribution, just like we have before. I'll distribute the x into that parenthesis. Then we'll distribute the 2 into the parentheses. And then finally the negative 3 root 7 into the parentheses. I don't really think this is too new to us, right? I mean, we just saw that with the I stuff. But now we've got the square roots, which is going to change things just a tiny bit when we looked at evaluating this stuff. So let's distribute the x, the 2, and the negative 3 root 7. Now we get to this last term, right? We got negative 3 root 7 times positive 3 root 7. So I've got 3 times 3. Let's write this up here. So the 3 times the negative 3, that would give us negative 9. But square root of 7 times the square root of 7 is 7. Yeah, very good. So that's really negative 63 right there. Then we'll write in down there. Well, let's just look at this and just see if anything can be eliminated on this. So, yeah, the 3x root 7 and the negative 3x root 7, those are going to cancel. And the 6 root 7 with the negative 6 root 7, those are going to cancel as well. I don't see any other, funny business right here, like the I squared stuff, or the square root of 7 times the square root of 7. So I do have that x squared right here. I've got positive 2x and another positive 2x, which combine to be a positive 4x. And then I've got a 4 and a negative 63, which would be negative 59. That's it. I don't know. We kind of look at those square roots and feel bad about it, but it's really not too bad. Let's go ahead and write in our formula, right? And the first thing I got is that square root of 22, and the other one I got is a negative square root of 22. So I'm going to change that to plus, right there in purple. You know, if you like FOIL or whatever, I'm just going to do the same technique. So I've got x times that parentheses, and then we'll distribute the negative 22 into the parentheses. All right, let's distribute those. So the x first, and then this negative square root of 22. And then at the end here, we've got a negative times a positive. So we know it's negative, but the square root of 22 times the square root of 22, just like that last problem, right? 22. And yeah, we got those two middle terms that are the opposites. So positive x root 22 is going to cancel out the negative x root 22. Those end up being 0. So I end up with x squared minus 22. That's it. Some of you noticed that from the beginning though, right? These are conjugates. And so we could have just said, well, this is the difference of squares. And that would be fine. Now we need a quadratic in that form, the standard form there at the top. But it says it wants a minimal leading coefficient. This has everything to do with the denominators in the two solutions it gave us, all right? So if we go back to the way we started with x minus one thing and then x minus the other thing, we're still going to fill those in. In fact, I should probably space these out a little bit. So one of the solutions they gave us, right, is 2/5. And the other one was 3/4. I don't know. It's really not too bad. If I wanted to get rid of those fractions, I would just multiply it by whatever the denominator is to get rid of it, right? But I'm going to do it with the whole set of parentheses. So this first set of parentheses, I'm going to multiply by 5, which when I distribute into that set of parentheses is going to get rid of that fifths of the 2/5. And with the 3/4, I would be multiplying that by 4. Right, so when I distribute that 4 into it, it gets rid of that denominator. Now what this does, though, it gives us coefficients of the x's, though, right? So it's still set of parentheses because it's multiplication, but things are going to change just a little bit. So distribution, I'd have 5x minus, now it's 2, 5 times 2/5. And this other set of parentheses, I've got 4x minus 4 times 3/4, 3. So these are the two, and this is going to minimize that leading coefficient because we're just getting rid of the denominators and the fractions. Okay, I mean, you could find multiples of it, which would be great, but this is how we get to the smallest leading coefficient. Okay. All right. So we need to distribute the 5x into that parentheses, and then I need to distribute this negative 2. Well, let's actually distribute the 5x and the negative 2 now. Now I've only got one set of like terms to combine right there, right? That negative 15x and the negative 8x. And we got 20x squared minus 23x plus 6. Done. Well, again, we're on the substitution theme. I wonder though, right? Because that's 0 times that 4 minus 5 stuff. I mean, it kind of goes away, right? But here's the nice thing about the substitution. So if you wanted to, you should be able to solve this without the substitution theme, even though one of the answers is a fraction. Okay? But with the 0, thing going on. So we'll say let u equals 4m minus 5. So u squared equals 4m minus 5, that quantity squared. Let's rewrite this then. So I've got u squared minus 0u minus 1 equals 0, which really just is u squared minus 1 equals 0, which is the difference of squares. So no real need to factor on this one. I've got u minus 1 and then u plus 1. This can equal 0. But again, I need to go back and replace the u with the original expression, 4m minus 5, and this is minus 1. And then I've got the 4m minus 5, but this one is plus 1. Well, this should equal 0. Well, let's go ahead and simplify these. So I've got 4m minus 6 and 4m minus 4. That should equal 0. So, again, just splitting these up, if I can get 4m minus 6 to equal 0, that would be true. So 4m equals 6, and m, we'll simplify that into 3 halves. There's my first answer. But also, if 4m minus 4 would equal 0, that would also be true. So 4m equals 4, and finally m equals 1. There's our solutions. So we're going to say that u is 1p minus 3, or just p minus 3. So u squared would be the same 1p minus 3, but we're going to square that binomial. Well, this gives us missed that 15 there. 15u squared minus 4u minus 3. This needs to equal 0. So we have a coefficient of u squared now that is not 1. So this is going to require factoring by grouping, right? So I've got 15 times that negative 3, which is negative 45. I need two factors of 45, negative 45, to add up to negative 4. Alright, so I've got those two factors. I'm going to split negative 4 up then into negative 9u and positive 5u. Well, looking back, we're going to factor these by grouping. And on that first term, I can factor out a u, but also a 3, which gives me 5u minus 3. And on this other term, I can factor out a 1. So I've got 5u minus 3. Again, we want those two binomials to match so that I can factor out whatever that is. So we'll factor out that 5u minus 3 from both terms. And then whatever's left there, 3u plus 1. And this equals 0. Now that we got that factored out completely, let's go ahead and replace the u's with p minus 3. Now we'll distribute the 5 and the 3 into those parentheses. So there we go, 5 and 3 there. And then we'll simplify those. Well, once again, if I can get that 5p minus 18 to equal 0, then we're in good shape. So adding 18 to both sides, 5p equals 18. Divide both sides by 5. P is 18 fifths. If you want to write that as mixed number decimal, I'm okay with that. But I don't want to, because I'm good with the improper fraction there. And then also, if we can get that 3p minus 8 to equal 0, that'd be good. It gives us a true statement. So add 8 to both sides, and 3p equals 8. Now divide both sides by 3, and p is 8/3. There we go. Now again, we should check, right?